Hello and welcome back to another session in mathematics. In this session we'll be looking at surds, but before that let us take a review of our previous lesson. Welcome back. In the course of today's lesson we'll learn multiplication and division of surds, and we'll deal with rationalization of surd. Okay, so let us start with multiplication and division of surds. Multiplication and division of surd. When we have root p times root q, remember I told us earlier that it's equal to root what? P q. This is one thing you need to bear in mind, and this is the multiplication. Then for division, when we have root p all over root q, it's the same thing as root p over q. Okay, just bear these two things in mind. It will help us in the course of solving multiplication and division of surds. So let's take some examples. Assuming we are given root 72 times root 75 for us to express. This is simply 72 first of all is 36 times 2, where 36 is a perfect square. Remember I told us earlier that you must have what? One perfect square in the square roots. Okay, so we have 36 times 2, and that will give us 72, of course. Then 75 can be divided by 25, which is a perfect square, to give us what? To give us what? 3. Yeah, so we have square root of 25 times 3. Is that correct? Now square root of 36 is what? 6 root 2. Then times, what's the square root of 25? 5 root what? 3. And remember we are dealing with what? Multiplication. We have this times this. So what do? We multiply the ones that are what? Outside by the ones that are outside, and the ones inside will multiply each other. So therefore we have 6 times 5 root 3 and root 2 times 3. Okay, the ones outside cannot multiply the ones inside. 6 outside here cannot multiply 3 inside. Okay, and 5 outside cannot multiply 2 inside. So 2 multiply 3 and 6 will multiply 5. Do you understand? So 6 times 5 will give us what? 30. And then 2 times 3 will give us 6. And that's just it. Okay, example number 2. If we are given the problem, let's say root 8 all over 2 root 3, all over 2 root 3. All we have to do here is to write down our root 8 all over 2 root 3 times, you pick the denominator here and multiply both the numerator and the denominator. What do I mean by that? You pick this and then you have 2 root 3 over 2 root 3. Understood? Okay, remember the coefficient here is 1. So 2 times 1 will give us 2. Root 8 times root 3, what do we have? We have root what? 24. 8 times 3 is 24. All over 2 times 2 will give us what? 4. 3 times 3 will give us what? 9. Is that correct? Now we then have 24 is 4 times 6. Okay, all over, what's the square root of 9? 3. Then 3 times 4 will give us what? 12. Is that correct? We have 12 here. So let's proceed. What do we have? What's the square root of 4? 2. And then that 2 times this 2 outside here will give us what? 4. Then root 6 all over what? 12. Remember now that 4 can go into itself to give us 1. 4 can go into 12 to give us 3. Therefore we have root 6 over what? 3 as our what? As our answer. Okay, if we are given a problem like, let's say this is number 3, root 72 over root 75. I told us earlier that this is equal to root 72 all over root 75, and that will give us 72 is 36 times 2. We've done that before. And 75 is root 25 times 3. Okay, square root of 36 is 6 root 2 all over square root of 25 is what? Is 5 root what? 3. Is that correct? So what do we do here? and we multiply through by what? The denominator, which is 5 root 3. So we have 6 root 2 over 5 root 3 times 5 root 3 over 5 root 3. Okay, so what would that give us? 5 times 3 and 5 times 6 here, the ones outside will give us 30, and then 2 times 3 will give us root 6 all over 5 times 5 is 25. Root 3 times root 3 will give us root what? 9, and that will give us 30 root 6 all over. Square root of 9 is what? Is 3. 3 times 25 will give us what? 75. Now looking at the denominator and 30, 5 can go into 30 to give us what? 6. 5 can go into 75 to give us 15. We have 6 root 6 over 15. Can any other thing go in? Yeah, 3 can go into this to give us 2. 3 can go into this to give us 5. So we have 2 root 6 all over what? 5. And that's the least we can go. So our answer is what? 2 root 6 over 5. So let's go over to rationalization of surd. Rationalization of surd. Okay, under the rationalization of surd, if we have a problem like root 2 over root 3 minus 1, all we need to do here is to multiply both the numerator and the denominator by what we call the conjugate of the denominator. Conjugate is just the change of sign. Okay, like in this we have root 3 plus root 3 minus 1. The conjugate of root 3 minus 1 is equal to root 3 plus 1. Do you understand? As simple as that. That's just the conjugate. Then when we take the conjugate, we now multiply everything here by this. So we have root 2 over root 3 minus 1 times root 3 plus 1 all over root 3 plus 1. Okay, now let us open the surd. 2 times root 2 times root 3 will give us what? Root 6. Is that correct? And then root 2 times 1 will give us what? Plus root 2. Root 3 times root 3 will give us what? Root 9, and root 9 is equal to what? 3. Is that correct? So we have 3. Then root 3 times 1 will give us plus root 3. Minus 1 times root 3 will give us minus root 3. Minus 1 times 1 will give us minus 1. You agree with me that this will cancel this? Then we'll be left with root 6 plus root 2 all over 3 minus 1. Is that correct? And then we have our answer to be root 6 plus root 2 all over what? 2. 3 minus 1 will give us what? 2. Remember, you cannot break this further. So that is our what? Answer. That's how rationalization works. So let's take one more example. Example number 2. If we are given a problem like let's say 2 root 3 minus 6 over root 3 plus 3 over root 27 for us to express. How do we do this? Okay, we start. We have 2 root 3, which is this, minus 6 over root 3 plus 3 over, what's our 27 here? Remember, 27 is something as 9 times 3, right? So we have root 9 times 3. We have 2 root 3 minus 6 over root 3 plus 3 all over, what's the square root of 9? 3 root 3. Okay, so we've gotten what? 3 root 3. And what would this give us? Okay, at this point, is there any other thing we can do? This 3 can eliminate this 3 to give us 1 here. Is that correct? So we then have 2 root 3 minus 6 over root 3 plus 1 over root 3. We then take the LCM of the denominator. Remember, this is over 1. So we then have taking the LCM of the denominator. We have our LCM to be what? Root 3. So 1 into root 3 will give us root 3, right? And then root 3 times 2 root 3 will give us what? 2 root what? 9. Let me say it again. This is 1 into root 3 will give us this root 3, and root 3 times 2 root 3, what do we have? We have 1 here. 1 times 2, 2, and then we have root 3 times 3, which is what? Root 9. 2 root 9, and square root of 9 is what? Is 3. 3 times 2 will give us what? 6. So we have here to be 6. Okay, then we have minus root 3 into root 3 will give us 1, and 1 times 6 will give us what? 6. Root 3 into root 3 will give us 1 times 1. We have plus 1. Is that correct? And then we have 6 minus 6 is 0, plus 1 over what? Root 3. So at this point we have 1 over root 3. What else do? We then take what? The rationalization, which is now 1 over root 3 times root 3 over root 3. Okay, and 1 times root 3 will give us what? Root 3 all over. Root 3 times root 3 is root 9, and root 9 is something as what? 3. So our answer is what? Root 3 over 3. We'll stop there. Okay, so thank you for being part of today's class. I hope you really enjoyed what we did. Okay, so to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to do justice to multiplication and division of surds, and we've dealt with rationalization of surds and conjugate of surds. So we'll stop here today. Do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your comment or questions on the comment section. Till we meet again in our next class, stay safe. Bye.